And then we'll move to our final speaker who is here. She is Zhu-Barker, is an assistant professor of soil science at UW-Madison. She's a soil biogeochemist who's dedicated to enhancing our understanding of land management practices and their impact on environmental health. Her research primarily centers on nitrogen and carbon biogeochemical cycles, delving into microbial and abiotic processes related to various greenhouse gases and air pollutants. And she'll be talking, including composting in her presentation today. So thank you for being here.
Yeah, thanks for the introduction. All right. Good afternoon, everybody. Hope everyone's still awake. All right. So today I'm going to talk about the organic material, or basically organic waste. Before I start my talk, I would like to ask you, when I mentioned about the organic materials, what's come up into your mind?
Manure.
Manure. What else?
Food waste.
Food waste. Anything else?
Crop residue.
Crop residue. Yeah, we are pretty much covered all I want to talk about today. All right, so let me see. Okay, so first, let's look at the municipal solids waste in United States. So currently, a few years ago, maybe I'm pretty sure now we produce even more. We have like 300 million tons of the waste being produced in United States. And among this waste, we have about 33% are organic materials. In this category, we have the green waste about 1/3. And we have food waste about 2/3. And they kind of like all consist to 33% of the compost. Of the organic material here. And also this this one you can see it's a food waste, right? And you can see it's like from 1960s and to 2018, we produce more and more food waste. And there have a lot of reasons behind of that. I'm not going to detail those reasons, but this is some very interesting thing. We can start to think about like while we are pursuing a lot of crop yield increase, but meanwhile we also produce a lot of food waste. And so I have a question here. Those kind of like food waste, where did it end up now? Where does it end up?
Often in the landfill. Yeah.
Yes, landfill. All right. That's what so this is landfill looks like. I have opportunities in the past to visit like a few landfills in California. One was in California, and I was shocked when I looked at that. Like a smell and also the surroundings area. Basically it's not livable, and all the groundwaters over there is not usable. So you can see visually they have a lot contamination to our environment. So not just about that, and think about from climate change aspect, landfill also produce massive of greenhouse gases. Right now it's contribute to 1.6% to United States in inventory. And meanwhile, it's also produce leaches, for example, the nitrate leaching and also other kind of heavy metal contaminants and organic compound contaminants, and also volatile organic carbon that sometimes you smell, and that contribute to your respiration issues we often encounter. Right now in the United States, we have about 23 states that have completely or partially banned the disposal of organic waste in landfills. But unfortunately, Wisconsin is not one of these 23 states. All right. So the landfill is also contribute to environment, also occupy our lands. We have about 3,000 active landfills right now we have, and we have over 10,000 closed landfills, which is basically we cannot use for anything. So the land, I believe is what my calculation was about, we occupy 0.1% of land in the US, and we designed it to, for the landfill. And this number is increasing because every year we have more landfill closed and we open a new landfill. All right, so that is kind of like a severe situation we have. And that is kind of leading down to the talk which I'm going to focus today is greenhouse gas. So greenhouse gases here is nitrous oxide and methane. As some of you might know already, nitrous oxide and methane are potent greenhouse gases that contribute to the temperature change in this globe. And also from the past years, and you can see the concentration of those kind of two gas, it kind of increase like steadily. So that's why it's like we are seeing so many extreme climate events happening right now all over the world. So besides like the one alternative way, if we want to reduce our organic waste into the landfill, one way is to composting those materials, right? To divert those organic waste from the landfill to be composting. So we are able to use the nutrients in those organic materials, but meanwhile, we may also be able to reduce the greenhouse gas emissions from those materials. So here I conducted a study when I was in California. We looked at the greenhouse gas emissions from the windrow pile that is come from the city. You know, we collected from the city the yard waste, and to observe to see how much greenhouse gas would emit and how that relates to our management practices.
Where in California was this site?
Was in Yolo County.
Which county?
Yolo.
Yolo.
Yeah. So it's kind of like in the central California.
In the valley. Okay.
Yeah. So this graph is the greenhouse gas emission graph. So this one is the y-axis. Both of them are one is methane, and one is nitrous oxide. And the x-axis is the time, like how long we did this compost pile. And here you can see we have a different sign over here. So the methane is a triangle. The red one, like this red one is after we turn, and also the red square is also after we turn. So first from this graph you can say after this red one, this is nitrous oxide, right? So after we turn, they have a lot of nitrous oxide emitted compared to before turn. But once we turn, and you can say, once we turn, you can see they have a much less methane emitted. This is before term, and this is after term. So we can compare here and with here. This is square one. So the turning practice of the compost windrow is kind of cause the change of the type of the greenhouse gas emitted. So basically, before we turn the pile, we have the methane is the main product of the greenhouse gas. But once you turn, after you introduce oxygen into the pile, and the methane will be reduced dramatically, but nitrous oxide will come up. So this is we observed there. So I accumulated their emission and look into different season, like how to see how seasonality impacted the composting. So we found out that during the winter, you can see the methane is the main emitter over here. Nitrous oxide is much lower in winter, but higher in summer and spring. And also, this doesn't mean like nitrous oxide is higher than methane. It's just because the unit which we use for the nitrous oxide is much lower than methane. So here is the cumulative warming potential. We can look at here, excuse me, let me try to move this bar. Yeah. So the global warming potential, after we convert both of the nitrous oxide and the methane into carbon dioxide equivalent. And we found in winter, they have much more greenhouse gas emitted compared to other two seasons. So this kind of give us some the implication about the management, right? How we are going to manage our compost pile to reduce the greenhouse gas emissions here. So one thing is by the moisture control, and also we can change the feedstocks. For example, the ratio of the, if we are going to do manure, right, then you can do the manure versus the wood chips to kind of adjust the ratio of that to increase the porosity of the feedstock, which can maintain the oxygenized in the pile to reduce the methane emissions. And also you can, turn in the piles a certain time. And also on top of this, I also did another calculation to compare, because we talk about we divert those kind of organic waste from landfill to be composting, right? So we need to compare them, those two approaches, which one is going to be more sustainable or reduce much less greenhouse gases. So if we think about if we produce 100 million tons per year organic waste, and if we just dump all of them into landfill, we can produce like the 94 million metric tons carbon dioxide equivalent of greenhouse gas per year. But if we use for composting, and of course this data I used based on California, and we only produce 15. So we can reduce the 75% of the greenhouse gas emissions. Yes?
Some part of that landfill is captured. Right?
Yes. Yes, that's a good point. That's what I didn't consider into the landfill over there, because it's more related. It's related to the technology and also the accessibility to this kind of technology. But that's a good thing. We are developing this kind of technology to capture the methane from the landfill. But this is another story. Okay, so we talked about the food waste, green waste, right? Another part of my study look into the manure. Dairy manure, how we are going to do the dairy manure to reduce the greenhouse gas emissions and also increase the nutrients, like especially nitrogen content in our final product. So here I looked into the dairy manure composting. I compared the raw manure versus the compost, like well-managed compost, manure there, to look into the nitrogen content and also not greenhouse gas, but nitrogen content management. So this study is conducted by a PhD student that I co-advised in UC Davis. And here, I would like to draw your attention here is the nitrate level. So during the 15 weeks of the incubation, the composting, and we found the ammonia concentration is much higher in the raw manure, but not in the compost manure. But when we look at nitrate concentration, and the raw manure didn't have any nitrate at the end. So think about, we have a lot of ammonia started in the raw manure, on ammonia there, but not end up in the product. So where those part of nitrogen could go, right? So just like when we think about nitrogen cycling, they have ammonia volatilization, they have nitrous oxide production and NOx production. So it's very likely the nitrogen would be lost through those pathways and through those products during the uncomposted manure process, which is static pile. If you just pile stuff over there, you will lose a lot of nitrogen. But instead, if you manage this compost pile well, and then you have a lot of nitrate in your final product. But this also raises another question or concern, because you have so much nitrate in your final product. So what's the nitrate leaching? What's the potential to the nitrate leaching over there? So to answer that question, and we did a follow-up study to sample the deep soil core underneath the compost pile to see exactly how much nitrate, or we can find any evidence for the fate of nitrate in this site. So we sampled until 30 feet down to the ground. And we did nitrate concentration analysis, and we also analyzed M15 and oxygen 18 signature in nitrate. So first, we can see this kind of bar graph is nitrate concentration. So we can say the nitrate concentration is pretty high on the surface of the soil, which is underneath compost pile. And then as you go deeper and deeper, and the concentration is less and less, which makes sense, right? But once you go down to the 12 and the 12 feet, and we barely see any nitrate exist in the soil profile. So then it come up with another question is, where did the nitrate go? Because they do have a lot in the surface, but not on the on the soil profile. So one hypothesis could be they might be leached out, right? Leached out into groundwater already before we hit into that point. Or they could be denitrified, which is converted to the nitrogen gas and back to the atmosphere already. So to answer that kind of question, we looked into the M15. So a little background about this M15 isotope is when you have higher M15 signature in nitrate pool, that means that most nitrate in this pool has been through the denitrification process. But if it's just leached out, they will have not this kind of difference there at all. Because leaching is a physical process, they will not make the signature of the M15 different. So using that kind of knowledge, and we look at this, okay, we see a lot of M15 being accumulated in the depths over there. So that kind of give us very like strong evidence and make us confident to say, okay, there is very likely nitrate in the deeper soil profile is being denitrified instead of being leached out. So that comes to the conclusion of this class is like composting didn't really cause the nitrate leaching concern in California. All right. So another part of the study is like a compost application. After we produce those kind of products, right? We have compost, and we need to put them into the field and to make their valuable, to make their like purpose over there. So how can we see the compost fitting into the sustainability, the frame of that, especially those that claim the smart agriculture, where we can see that fit. So first, the compost can be considered as a sustainable strategy because it brings a lot of carbon into the soil. And also the compost, after the role of compost in like nitrogen cycling is very variable. That is because the nitrogen cycling is pretty complicated, and also the compost is very variable there. Normally we use carbon nitrogen ratio to determine, it's like, okay, this compost is being like promote nitrogen mineralization or going to immobilization, but sometimes it's kind of very hard to just based on the carbon nitrogen ratio here. So this study is conducted by my postdoc in UC Davis. We applied compost in olive orchard, and we looked at the like olive tissue nitrogen first to determine the agronomic benefit to see if compost really can improve the nitrogen uptake by the crop. So first we can see there's three pie graph, there's three graphs, and we found that they have more nitrogen uptake, like nitrogen concentration in the leaves and the fruits and the branch is more higher than the non-compost there. And also on the far right, we did, oh, they didn't show up here. Anyway, so we also determined the proportion of the nitrogen from the fertilizer pool versus from the soil plus compost pool. And then we did find that using compost kind of promoted the crop uptake fertilizer nitrogen. That is kind of very interesting results for us, and also it's like a kind of test our hypothesis that using compost can help the fertilizer nitrogen use efficiency. And another part, we looked at the greenhouse gas emissions, and here we looked at the nitrous oxide emissions. For the nitrous oxide emissions from all our like fertilizer level treatments, and we found out that, so this is like control, no compost, and this we are after applied compost. So the use of compost helped us to reduce nitrous oxide emissions from the field over there. Okay, so this will come to all the summary, which I have for today's talk, is the takeaway information first. It is true, the composting process will emit greenhouse gases. That is very true, but it's much less than landfill. If we put this part of organic material into landfill, we produce like much higher greenhouse gases. And also on top of the composting, if we do the management correctly, like doing the proper window management, then it can further help us to reduce greenhouse gas emissions. And also composting process did not contribute to nitrate leaching in California. But in Wisconsin, the story might be different. So that's why we needed to conduct further research over here. The reason for that is because the climates in those two states are quite different. And also the compost application can reduce greenhouse gas emissions from the agricultural soil in California. And the reason is that because after we put compost, they have a lot of carbon put in there. And then we have a nitrogen fertilizer put in there, so they can potentially to immobilize some of the fertilizer into the organic nitrogen pool, and then slowly release this part of nitrogen to the crop. So that is like the way they can help the crop to increase the nitrogen uptake from the fertilizer pool over there. All right, so that will conclude into my talk today, and I'm welcome any questions, any discussions.
I do have one question. So if you are a home composter, how important is it that you aerate your compost pile to do what you said to reduce the emissions coming off of your home compost pile.
Yeah, I think that is very important. I would suggest if you have, enough resource, if you have resources to turn your pile, I would like suggest you do that. Actually, especially in the first 2 weeks, probably you want to do it every other day. And it's not just because we wanted to reduce greenhouse gas emissions. It's also that will increase the nutrients content in your compost, the final product, and also it will help us to they promote the process much faster. So from your raw material to final compost, maybe will take only like 2 weeks, 2 months for you if you term manage well. But if you don't, like if you're just sitting there, maybe take like 6 months.
Okay,
Mhm.
great, thank you.
Yeah, did you say that it was possible somehow to convert nitrate back to elemental nitrogen and then release that to the atmosphere?
Mm-hmm. Yeah, it's so you're asking is how possible that it would be?
Yeah.
Yeah, so this is another thing very interesting about compost pile, right? So they have a lot of carbon over here, like in the leachate, they're going down there. So when the carbon is going from top down, they provide the substrate for denitrifiers to do the work to denitrify nitrate. So that one is like we can say is we didn't analyze the final product there, but I can hypothesize we have like very much higher than nitrogen gas compared to nitrous oxide in that side, because just they have a lot of carbon over there. The environment is very anaerobic. So denitrifiers love that kind of environment.
Right, because pure nitrogen is not problematic as far as environmental concerns go.
Yeah, no, it's not. Yeah.
This is exciting in a couple of ways, but I noticed that you were mixing manure with wood chips.
Mm-hmm.
And it seems that it might be a better source of carbon, given one of our earlier talks talked about the fact that wood chips sequester carbon longer than say grasses or field stubble or something like that. The other is that for the turning, for an agriculture, industrial agriculture, that it seems like if you're not talking about adding more machines to a particular farm, maybe a service that does the composting on site at the different farms or at CAFOs or near, whatever it would be an exciting opportunity. I've seen some of the windrows in place while driving through the countryside. Occasionally you see composting windows, but not in a large scale.
Yeah, it's not like I know in California it's a lot now because all this kind of thing happening. In Wisconsin, actually, I was like I had an opportunity last year in January. Actually, it's in this year in January, to tour a farm outside of Wisconsin. Some of you might know the name of the farm, the AG. But anyway, so and he has like the big compost turner. And he provides the service to the surrounding farmers.
Yeah.
So he composts his manure and everything. Even the compost it can go in during the winter. That was a big surprise to me. I was very glad to see it's like we can do the compost during the winter here. Yeah.
I'd love to see something similar that would work on the house scale, because I this year for the first time in a long time, I did a compost pile where I turned it. It's a lot of work.
Yeah, it is. It's like if you have like a good equipment, and you still have to have the person to operate that, and it's pretty frequently first a couple weeks. So if you want your compost to keep going, not die out, it's a lot of work. But we are all kind of work together to figure out the best way.
That would be a good technology for the engine, right? You home composting turner.
Well, I know the engineering department is looking for, in school, there's a class that I heard about this year where they look for interesting things to turn their students loose on, creative technologies, and a home compost turner.
They do sell a stick that's like an aerator that can go in
Well,
and
there's a little
stir
tumbler,
it.
that's
They
even
do
smaller
sell
scale.
that.
Yeah,
They do
I've had
sell
one of
that.
those too,
It has
and
like
that does work.
sort of an edge to it, yeah.
Is there some outlet that you've explained, sorry, I came in late, but you had some, best practices or good practices that are going on in California, but is there some sources for like you're saying, for the home, like good composting practices, or where do we need to be kind of telling people these things?
Yeah. Yeah, it's this is like coming to so when I was in California, everything is like, because the city has the composting program and you don't have to do your own compost. So that is like which I think I see the big impact in the whole neighborhood and the whole state in terms of the greenhouse gas emissions, especially climate change mitigation. And also like soil health project that is bigly rely on this compost being produced from different facilities. But ever come to here and we don't have this program from the citywide, so we had to do the personal thing. So what I did, I have a compost pit in my backyard, but unfortunately I was not able to turn. It's just because, we have a lot of soil over there and just impossible. But I was thinking about next year, I'm going to start like a real smaller scale of the compost pitch, which you can turn over to the next one, which they can be close by, is able to turn manually. So that is like I don't have.
That's a good point, though, having cities do that. I mean, the city of Midwest I live in, they do have a composting place, and I see tractors there, and they're turning it over. I never really thought about the science behind it.
Yeah, I think for City of Madison, you can take your
You
compost.
can, but that is like every city they need to do that effort to do that. Some people they just don't drop. Like for me, like sometimes like when I get super busy, I just dump my stuff into the trash. That's the easiest way, right? But it's not the right way. So let's use when the city come in, what happened is like it seems like you will recycle your trash. They will come in to take it every week. So you have a bin specifically sitting there for composting.
Yeah.
So that you can add into our bill like $7 or $10 per month, but it's not very big compared to you are going to do this by yourself.
Your chart at the beginning showed the pie chart and thinking about compost. In Madison, it's mostly leaves, right? It's those are the leaves that people foolishly get rid of when they should be keeping them. But those are then. It used to be the county had a composting facility up on Highway 19. They had to close that because they lost the contract with the city because they hadn't increased their fees for something like 10 years. And when they did, to cover their costs, Madison said, no, it's too much.
Well, Ulbrich used to have big composting, but because of jumping worm leaves was a pathway to spread jumping worm. And so that whole program stopped, which was unfortunate. But yeah, not raking up leaves or mulch mowing them, or they should be on yard waste stuff.
Yeah, and I feel it's like definitely we need like have everybody's effort, all different parties put in together to move this forward. If it's only on one party, that would be too much. And but if everyone contribute a little bit, then that will be really make, like to the theme of this conference, sustainability. That's what we talk about. Yeah.
So as far as recommendations for where farmers, for example, or entities should be siting their compost windrows on, you were mentioning that nitrate leaching is not actually leaching the groundwater, it's denitrifying, right? And that depends upon a kind of open soil structure, right, to provide aeration. So if a farmer is doing it on like a concrete slab, for example, does that prevent the leaching at all, and then the end product has more nitrogen, or is it actually leaching off as runoff from rain?
That's a great question. So definitely will prevent leaching in that site because it's concrete, but will provide more opportunity for runoff.
Right.
But for runoff, we can design a certain way to prevent that kind of runoff get into our, like a water body. For example, if you have some like a grassway or like a water protection area, so we can prevent that problem I would say not very easily, but relatively easier.
So would the final product then have potentially more nitrogen as a result because it's on this concrete pad that then is also protected, or?
That's a good question. I do not think it will have more nutrients, or nitrogen end up in the compost when you if you compost on the concrete versus you compost on the top of soil.
Mhm,
I
okay.
don't think that difference will change the content in the compost itself, but it definitely will change the distribution of nitrogen and the soil and the carbon in the soil profile underneath that compost pile if you choose to on top of the soil.
Right.
Yeah, that also come to the question is like a type of soil, whether you are going to compost on top of sandy soil or on the clay soil,
Yeah.
if you have a choice.
Right.
And maybe you said that the concentrations were highest, of course, in the first few inches. The microbial action in the soil of that first few inches might be a lot more potent than a concrete slab. So it could be the soil bacteria, not the bacteria that are in the compost that are doing the denitrification.
Yeah, yeah, I think that makes sense there too.
All right, thank you so much.
Yeah.